Question 36 from the Ohio Geometry Spring 2019 from the Ohio Geometry Spring 2019 release question. This one is a doozy. To estimate the area of a circle, Henry divides a circle of radius r into n triangles. So an unknown number of triangles. We don't know how big the circle is. As shown, it uses the expression h over 2, that's the height of a triangle. In the picture, h would be here, times the sum of the bases to estimate the area of the circle. In the expression, the variables b1, b sub 2, up to b sub n represent the base lengths of each triangle, and h represents the height of the triangle. Okay, so far this is, wow. Henry claims that the more triangles that the circle is divided into, the closer the estimate will be to the actual area. Now that seems reasonable. Let me just give you an example. Let's say this is our circle, and let's say that he only did, say, 3 triangles. We'll say 4 triangles. What do you think? Do you think the area in these 4 triangles is more or less accurate than the area in these triangles to represent the area of this circle? So pretty obvious that the more triangles you have, the more it's going to approximate that area. So I can certainly get behind that, even though that was never questioned. But we want to understand and try to make sense of what they're saying. Which statement about Henry's claim is accurate? Now let's keep in mind that to find the area of a circle using conventional methods is pi times the radius squared. This dude's claiming that this is a good estimate of this. So let's see how this shapes up. A, his claim is accurate because as n gets larger, that's the number of triangles, the value of h gets closer to the value of r. So is that correct? Let's go back to this first picture that I drew. And let's just give a gross example of this triangle. This is the radius. This will be h. Right now, I only have 1 triangle drawn, but we could probably fit 4 of those same size triangles in here. H is not a good representation of what R actually is. But if you look at the picture we have here with a lot more triangles, H is getting closer and closer to touching the circle, which means it's getting closer and closer to being size of the radius. So that makes sense to me. So it says H gets closer to the value of R. I can certainly stand behind that. This one says that as well. The other possibility, it says h gets closer to the value of twice the radius. That's what B and D are saying. That, to me, that's insanity to say that. So I'm eliminating B and D right now. Now we're down to A and C. Second part of A, the sum of these fellas approaches 2 pi r. Now in our formula, we want it just to be, so we're saying that the r is coming in for the h's. Let me take his formula here. He's saying the area of a circle is about h over 2 times the sum. And he's saying that h gets closer to r, so we can replace h with r. So now we got r over 2. We don't want that 2 there. And then if this sum of these b1s and b2s up to bn is approaching 2 pi r, I replace this with 2 pi r. Check this out. The 2's cancel, and now you're left with pi r squared. So to me, A makes the most sense. Up to this point in my life, I've never approximated the area of a circle this way. Perhaps I should have done that at this point. being a math teacher and all. But A makes sense to me because if you put things into the formula, it gets us back to pi r squared, which we know the area of a circle is. So this is a tough question. If you don't completely understand it, don't lose sleep over it. This question is for the people that find geometry so incredibly easy and mundane that they need a little bit of a challenge.